Alright, let's talk a little bit about mutually exclusive events. This is something that should be familiar with to you based on our Unit 3. Okay, so let's look at the first example here. Consider some events. So let's label this. Event E is rolling a sum of 8. Okay. Event F is rolling a sum of 4. And D is rolling a double. Okay, and so I've given a sample space here. This is the sample space. That's all of the different outcomes when you have two dice. Okay, so which ones give me a sum of 8? If I add numbers up, this would give me 8. This would give me 8. This would give me 8, 8, and 8. Okay, what would give me a sum of 4? 4, 4, 4. And which ones are doubles? Here, 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 and there. Okay, so those are the events. I've listed them here. We say that events E and F are mutually exclusive because they do not have any common outcomes. Okay, if you look up here, adding to 8 and adding to 4 are not the same. Okay, none of them are in common. All right, we call those mutually exclusive events. They are called disjoint sets because they cannot occur at the same time. Okay, the outcomes E and D are not mutually exclusive events because 4, 4, two 4s, appears in both sets. These are not disjoint. Okay, and I've used some Venn diagrams here to show the two situations. You can see E and F are mutually exclusive, while E and D are not mutually exclusive because they share that one event. Okay? So let's try to look at some examples of that. Determine which of the following events are mutually exclusive. Okay, attending school and having a job. Can you do those at the same time? Sure you could. So those are not mutually exclusive. Being a member of the girls' basketball team and the boys' basketball team. Well, you can't do that. You can't be on both. So those are mutually exclusive events. Rolling a 2 and rolling a 3 on a die. Well, you can't do those at the same time, right? Okay, driving a car and talking on a cell phone. Well, that should be mutually exclusive, I guess, unless you have Bluetooth. So maybe we'll put a star by that one and kind of say it's possible. Okay, maybe that's a bad example. Finishing first and second? No, can't do those both at the same time. Okay. Finishing or selecting a diamond or a jack from a deck of cards. Okay. These are not mutually exclusive. Why? Because there is a jack of diamonds. So it is possible to get a card that fits both sets. Okay, selecting a king or a queen from a deck of cards. Well, you can't do both at the same time. Okay? So I think you know this, the addition rule of probability. If there's or, that means addition. So or is addition, and means multiply. Okay? The formula for mutually exclusive events, the probability of A or B, we add the two probabilities. The probability of, and this is just another way of writing it. This is or. Okay? And the formula for when they're not mutually exclusive. So this means there's, when I see this, I think of overlap. There's something that they have in common. Okay? So the formula just changes a little bit. You might want to put that on your formula sheet, but sometimes you don't need the formula. You can do this without the formula. Okay, so let's take a look at a couple of examples here. Okay, to move, Janik must roll either doubles or a sum of 7. Okay, so let's show where those things are. Okay, doubles. So that means having two of the same. Okay, we can have here, 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 here. These are all the doubles. Okay, or sum of 7. Sum of 7 would be adding the dies, or I guess the dominoes or dies or whatever these are, and getting a 7. And you can see those are mutually exclusive events. Okay, so if they're mutually exclusive, what's the probability of doubles or sum of 7? Well, since they're mutually exclusive, this is the probability of doubles plus the probability of 7. Okay, and the probability of doubles is 6 out of 36, and the probability of 7 is 6 out of 36. So this probability of 12 over 36. Okay, let's try the next one now. Recall a board game that Janik and Violetta are playing. According to a different rule, if a player rolls a sum that is greater than 8, okay, so let's highlight greater than 8, or a multiple of 5, the player gets a bonus. What are the multiples of 5? 5, 5, 5, 5, and then 10, 10, 10. So these are not mutually exclusive. So I'm going to say non-mutually exclusive events. So what is the probability of greater than 8 or a multiple of 5? Okay, since they're not mutually exclusive, to do this you're going to get what is the probability of being greater than 8 or, so that's plus, the probability of a multiple of 5, but then we have to subtract the probability of their overlap of both, because we don't want to count them twice. Okay, what's the probability of getting more than 8? That's 10 out of 36. What's the probability of a multiple of 5? That's 7 out of 36. Is it 7? Yeah. And the probability of both, that's 3 out of 36. So this is 14 out of 36. Okay, so you might want to write that formula down if it helps you. But you know, in this case, you probably could have just counted, because you wouldn't have counted 10 twice. Okay? Alright, let's try the next one. Oh, look at this, a Venn diagram. School newspaper published the results of a recent survey. Are skipping breakfast and skipping lunch mutually exclusive events? Well, let's look at the survey first. 62% skip breakfast, 24% skip lunch, 22% eat both breakfast and lunch. Okay. So where do these numbers go? Well, 22 doesn't fit. This is like they're outside. Okay? And this is since this percent, this is out of 100 total. Okay? And then it says, I'm just going to write this in here. So if we skip breakfast here and skip lunch here, we know that 62 are in this circle. And I know that 24 are in this circle. But 62 plus 24 plus 22 does not equal 100. Okay? So what is this? How much bigger is this? This is 86. This is 108. That doesn't equal 100. This tells me that 8 are sort of doubled up. So let's go back into here. 8 must be skipping both. Okay, and now since this is 62 here, 62 take away 8 would give me 54. And 24 take away 8 would give me 16 here. If I add this all up, does this add up to 100? 30, yeah, it does. Okay, so let's answer my questions. Are skipping breakfast and skipping lunch mutually exclusive? No. Okay, 8% skip both. Okay, Determine the probability that a randomly selected student skips breakfast but not lunch. Okay, well that's going to be 54 out of 100. So 54%. And C, determine the probability that a randomly selected student skips at least one of breakfast or lunch. At least one of. So this is the probability of skipping breakfast, or probability of skipping lunch, or probability of skipping both. So 54 plus 8 plus 16 is 78%. Okay? Now we could have done that another way. We could have said, what's 100% take away the ones that eat? Again, that gives me 78%. So that's like that don't skip, not skip. All right, next example. I think we'll skip this example. I don't think you need to know how to do it. You can try it on your own if you really want to, but I think we'll go on to example 5. Okay, car manufacturer keeps a database of all the cars that are available for sale at a dealership in Western Canada. For Model A, the database reports that 43% have heated leather seats, okay, and 36% have a sunroof, and 49% have neither. All right, so here's the database. Again, it's going to be 100. And it says that 49% have neither the heated seats or the sunroof. Okay, determine the probability of a Model A car at a dealership having both heated leather seats and a sunroof. Okay, so we know this is 43 and we know this is 36. And we know that 43 plus 36 plus 49 doesn't equal 100. Okay, this is going to give you 92, 98. This is 128. This must mean 28 overlap or are counted twice. Okay, and then since we know this is 43, take away 28, this is 15. We know this is 36, take away 28, this is 8. Okay, and it says determine the probability of a Model A car at the dealership having both heated and leather seats. So the probability of both would be 28 out of 100, which is 28%. All right. I'd like you to do a couple of questions for homework. Let's give you page 338, numbers 2 to 8, 13 to 15, and 19.